So we're here for questions 15 through 22, I believe. We're continuing with some trigonometric ratios. So we're going to be looking at which of the following must equal sine of r. Okay, so here's r. We need the sine of r. Sine is so, which is opposite over hypotenuse. Okay, so we need to look at the sides that are opposite and the hypotenuse. So which side is our hypotenuse? It's going to be this one. Okay, the opposite side for r is here. If you recall, your hypotenuse is across from your 90-degree angle. Okay, 90 degrees. We were talking about that. It's always the longest side. It's always across from here. We wrote those in our previous notes. So this is opposite and hypotenuse. There's the sine of r. So we need to look at what's the cosine of r. Well, the cosine is the adjacent over hypotenuse. So that's obviously not going to be the same as opposite over hypotenuse. Can't be that one. The cosine of s. Okay, so s, cosine is adjacent over hypotenuse. All right, so if I'm looking at S, the adjacent side here would be S's adjacent and hypotenuse. So that is the same one. That's the match, right? If we have the tangent of R, that's opposite over adjacent. So it's obviously not the same as opposite over hypotenuse for R, okay? Not those. And the sine of S, excuse me. The sine of S would be its opposite, which would be way over here in the hypotenuse. So it was not a match. This is the only one that's a match for that question. Okay, moving on into our next unit where we were looking at arc lengths. Here is the arc length formula. The length of the arc is the measure of the central angle. Okay, measure of central angle. M means measure. You may not remember that, but that's what that means. Measure of the center angle divided by 360 times 2 times pi times the radius. Okay, that's the radius. Remember, the radius is the part that goes from the center of the circle to the edge. Okay, a diameter goes the whole way. A radius goes here. So this is our radius. A central angle has its vertex at the center. This is the 45-degree central angle. Okay? We're looking for the length of this arc, DE. This section right here. That's what we want. Here's our formula. All we have to do is plug that in. 45 degrees divided by 360 times 2 times pi times the radius, which in this diagram is 16 millimeters. So we're going to do this way. If I don't want to mess with my fraction right now, you could just combine 2 times 16 and say that's 32 pi. Okay, go ahead and combine that. Then 45 to 360. I don't have my calculator handy. Forgot to grab that. The other thing I forgot to point out is they say, what is the length of arc DE in terms of pi? In terms of pi. We're not going to multiply pi out on our calculator or at all. Okay, pi will be in your answer. Leave pi in answer. You'll see that all 4 of your answer choices have that, so not really a problem. 45 divided by 360 is 0.125 times 32 is 4. Okay, so on my calculator, sorry I didn't have it over here, but all I did, here we go, was I divided 45 by 360, that was 0.125, I took my answer times 32, that gave me 4. So this is 4 times, and I already did this part, sorry, 4 down here. Reread it like this. plus 45 over 360 times 32 with pi. So it's 4 pi because I didn't multiply the pi in my calculator here. I just did my division, multiplied by 32, got 4 pi millimeters, because that's what we were measuring in. So there's your answer. A lot of these are, if you know the formula, and since I'm giving you this review and it has the formulas on it and I'm showing you how to use them, your final should be pretty nice. Okay, I did put the entire packet. If you don't have this packet, it is uploaded at the beginning of the review module. You can either download it or and print it. I will have copies on Monday. It would be helpful if you've got all of this done before we come in on Monday. Okay, then we could ask questions and have some really good opportunities to review before the final. Triangle perimeter with an end circle. Okay, so here's a triangle perimeter around the circle, an end circle. So circle 0, or O, sorry, circle O, okay, we name them with an O, is inscribed, which means he's inside, triangle, that's the symbol for triangle, X, Y, Z. What is the perimeter? That's the outside. Outside. We've talked about perimeters before. If you've watched any movies or played any of the Army games or whatever online, you set up perimeters. Okay, we talk about those. What's the perimeter? I'm given that this side, okay, when we have a circle inscribed in here, the triangle meets at the point of tangency on here. What it does is, if you'll remember, it creates best friends. That was my analogy. So I have the length of 7 right here, okay? And his best friend is going to be right over here. So that means that this is 7, okay? First time doing this video at home, I'm going to see if these highlighters show up on here. Then I've got section 14. Well, that works pretty good. His best friend is right over here. So that means that his section across here is 14. Then we've got, started out with blue. Should have done the pink and the green for Bella, but here we go. All right, I've got pink. How are you showing up? Not bad. 12 here. That means his best friend is over here. Okay, so I can mark a 12. Now, to find the perimeter, I have measurements at all my segments. All I have to do is add them all up. 7 plus 14 plus 14 plus 12 plus 12. And, you know, we love calculators. If I could use a calculator properly, that would be great. It's only 10 to 11 at night for me to do this. Okay, so there we go. I end up with 66. Is that one of my answers? Yes, it is. They didn't give us a unit of measurement. So again, you can choose puppies, ponies, pickles, kittens, whatever. Okay, 66 units. Next, we have our circle equation. A circle is represented by this equation. This is the standard form of an equation. We also had the conic form, and I don't, oh, actually, we didn't have that. That was intermediate algebra. You'll get that next. Anyway, here's our standard form for the equation of a circle, which shows the center and the radius. Okay, so this number right here is our r. This number right here is our y, or it's also labeled as k in our formula. And this number right here is our x, and he's also known as h in the original formula. All we need to know is this is x, this is y, this is the radius. So I'm going to take the square root of whatever my radius is. I'm going to change the sign here. And I'm going to change the sign here. These circle equations, I like these. These are pretty nice. So I have a positive 2 here, so he becomes negative 2. I have negative 3 here, it becomes positive 3. There's the center of my circle. My radius, if I take the square root of 25, that's 5. So I'm looking for an answer that says center, negative 2, comma 3, and a radius of 5. Center, negative 2, comma 3, radius 5. Happens to be the very first choice. Yay! Obviously, if you get a 5, that would eliminate those two choices. Then just be very careful. Take your time when you're doing tests. Go back and review. Make sure that you don't accidentally mess up choosing the wrong one just because they're trying to trick you with flipping the negatives around. Okay? That's why I wrote in here, you do change the sign. All right, let's look at 19. Oops, next page. 19. Angle measures. Angle measures. What is the measure of angle F in the diagram shown? Here's angle F. Okay, here's angle F. It's represented by this whole term, 5x minus 2. Well, we've also got angle G over here at 4x plus 10. We have 7x minus 25 is E. Now that I look at this, now that I look at this, there's technically another way you could solve this. And I think I could probably tell you a few people who might remember that this is a quadrilateral, all 4 sides, and they have to equal 360 degrees. But okay, we had to do an edit on, I had to do an edit on number 19. I needed to change these terms here. So instead of having the 4x plus 10, now we have 4x minus 10. So if you have that older sheet, make sure you make this adjustment, 4x minus 10. Also here, we change it to 7x plus 25. Right? It's still opposite angles equal 180. That's the point of this exercise. So we rewrote our equation to say 4x minus 10 plus 7x plus 25 equals 180. Then we do our math. We're still going to get 4 and 7 is 11 x's. Then we get negative 10 and positive 25 is plus 15. Okay? Equals 180. Then we're going to subtract 15 so that I can get 11x by himself. Those two cancel out. Subtract 15, I get 165. This time when I divide by 11, I get x equals a nice even number, 15. Okay, so that's what x equals. That's not the measure of angle F. To find angle F, I'm going to have to now plug in x into 5x minus 2. That's the term that stands for the measure of angle X. So 5 times 15 minus 2. Get your calculator out, do 15 times 5 minus 2, and you get 73. So 73 is our final Jeopardy. It's 73 degrees. Here you go. Answer C. All right. Let's take a look at equation of a circle. Back to circles. They skipped around. Which of the following is the equation of the circle? So we saw in our number 18 the equation of a circle is this guy down here. Okay? And I told you that this was your x coordinate, this was your y coordinate, and that this was your radius. All right? What happens when we have a diagram over here on our grid? I'm going to have to look. I think they labeled it. It's a little hard for me to see. But anyway, this is 1, 2, 3, 4 for x. I believe that says 4. And a negative 1 for y. So the coordinates over here are 4 for x and negative 1 for y. When we pulled those coordinates out of that previous equation on number 18, we changed the signs. So we're going to change signs again. When we pull it off the graph, we're going to change the signs to put into equation. So what we'll be looking for in our answer is going to be a -4 and a +1. So -4 and a +1. Okay, that eliminates this one, and it eliminates this one. Okay, this is how, these are good test taking capabilities. You just have cut your answer choices by half. Now we've got -4 and +1. What about this guy? How do I find him? On this diagram, you can count. I have 1, 2, 3, 4 sections right there. Okay, so in here, that radius is 4. But when we took the radius on our previous question, we had to take the square root of it out of the equation to be able to plot. So we're going to square him. So when I square him, 4 times 4, I'm looking for the 16. Okay? That is all you have to do to find him. On our next one, we are back to circles, but a different type of circle. We're looking for a chord. A chord in a circle goes from one side to the other. Okay, this would include, this is the diameter right here, so it would include CD. So CD is a chord. Okay, AB is a chord. AP, that does not go all the way across. That one is a radius. Okay, that's a radius. So they're saying which statement correctly identifies an element in circle P. I've labeled it, you know, that chords in a circle. So they're looking, that's your clue, that they're looking to see if you know what a chord is. So CD is a radius. I already told you CD is a diameter. It goes all the way across. Okay, CD goes all the way across, diameter. AB is a chord. Okay, I told you that. AB is a chord. He goes. So this is definitely it. Let's double check. Is angle A a central angle? Earlier I told you the central angles have a vertex at the center. Angle A, his vertex, that's out here on the edge. Not true. Not true. PA is a diameter. No. I just already told you that's a radius. So we've double checked our answers. We're good to go. We have one more question to do for this question set. And then I'll make a new video for the next 7 questions. So a right angle in a circle. In circle M, here we are, which angle is equal to 90 degrees? All right, so the rule is if an angle has a side that comes through the diameter, this is how you identify it. This is going through the diameter. That the opposite angle is going to be the 90 degree. Okay, so now how do I name that? We've been over it in a previous video that we name our angles like dot to dot, A to B to C. So that's A to B to C, or to C. So that's naming an arc. Okay, that's not him. That's not this guy. He's naming something with B at the center. We're looking at the center one because that's going to tell us we're looking for something with A at the center. So CDM, that's not him. He's way over there. Let's see, AEM. Nope, because that puts E at the center. Here's BAE. BAE. There he is. Okay? Have to remember how to name angles. All right, that's the end for this video.